will continue 1-3 with a look at variance and standard deviation now. Okay, so we're going to look at the mean deviation. This is another measure of dispersion. So we have a problem here. We need to get a better number. The range of a data set is basically ignoring all but the lowest and the highest numbers in that set. So we're just ignoring everything in the middle. It just acting like it doesn't even exist. So a possible solution might be to find the distance between each data point and the mean. So if we know what the mean is, the average, we can find out how far each point is away from that. This is known as mean deviation. So let's find the mean deviation here for this set of data. So the first thing we need to do is find the mean of this set of data. Okay, so we add all those up and we divide by 10 and we get a mean, or x bar, of 23. So now we want to find the deviation of each term from the mean by subtracting. So we take 32 minus 23 and we get 9. We take 18 minus 23 and we get negative 5. So we're going to get positives and negatives here. We're always just taking whatever our number is in the left column and we're subtracting the mean. So the mean deviation is found by adding up all of these numbers and averaging them. But we have a problem. It's 0. Try it yourself. Add up all of these numbers in the right column, you'll get 0. And then 0 divided by 10 is going to be 0. So the mean deviation itself is borderline worthless. No matter what the set of data is, the mean deviation average is always going to be 0. We can look at something called mean absolute deviation though. So we find that by adding up the absolute values of a set and then averaging those. So remember, absolute value is how far away from 0 a number is. So if we're positive, we don't change anything. 9 is 9 away from 0. But when we look at negative numbers, we basically just drop the negative. So negative 5 is 5 units from 0 on the left, if you're thinking of a number line. So the absolute value of negative 5 is just 5. So this keeps that average from being 0 because we're only dealing with positive numbers. So find the mean absolute deviation of this set of data. Okay, so if you added up all of those numbers, the absolute value of all those numbers, you should have gotten 70. And then if you divide that by 10, the mean absolute deviation is 7. So on average, each of these numbers is about 7 from that mean of 23. So here's a problem. Absolute value is kind of a pain, especially the more complex things get, the less we really want to use absolute value. So mathematicians, whenever they were coming up with these statistical things, they decided to get around this problem by squaring the data instead, because we deal with squares all the time in math. So the new average of the squared data is going to be called the variance. The symbol for variance is a lowercase Greek letter sigma squared, and that's right here. So remember, capital sigma, uppercase sigma, was that E looking thing that we used to sum up a bunch of numbers. Variance is a lowercase sigma, and if you think about it, the reason they might have used that is because we were using uppercase for sum, and for the variance we need to add up a bunch of numbers and square them and then take the average of it. So it's related to the sigma that we were already using. So lowercase sigma seems like it might be a pretty good idea for a symbol for that. Alright, so let's look at this set of data again. Now, instead of taking absolute values, the third column, we are going to square them. So we got 81, because that's 9 squared. We get 25, that's negative 5 squared. So the squares are always going to be positive, and generally it's easier to do calculations with squares than it is with absolute value. So we get a sum of 766 for all of those squares. So our variance, our sigma squared, is going to be 766 divided by 10, which is 76.6. That is the variance of this set of data. So here's a smaller one for you to try. So find the variance of this data set right here. Okay, the mean of the data set is 19.4. The sum of all of the deviances squared is 317.2. So the variance, when we divide that by 5, is 63.44. Okay, so now let's look at the last dispersion measure we're going to do in this section. We're going to talk about standard deviation. This is the most commonly used measure of dispersion. Whenever you see some kind of statistical chart, a bell curve, whatever it is, a lot of times you're going to hear about standard deviation. So the problem with variance, we're not only squaring the deviance, but we're also squaring the units. So if I'm talking about dollars, then my variance is going to be talking about dollars squared. If I'm talking about how many hot dogs my vendors are selling at a baseball game, then when I do the variance, I'm talking about hot dogs squared. Well, I don't want dollars squared. I don't want hot dogs squared. I want to know what the spread of my dollars is. I want to know what the spread of my hot dogs is. So standard deviation takes care of this problem because standard deviation is just the square root of the variance. So you find the variance just like we just did in the last couple slides, and then you just take the square root of it and you're going to have the standard deviation, and that's going to be a pretty good measure of dispersion. So if we have a set of 5 pieces of data like we did with the last variance, it's not too bad to calculate standard deviation. We would just take the square root of that last number we found. So list of numbers, small list of numbers, it's not too bad to find. But if we're talking about a frequency table, don't do it all by hand. We could be talking about lots of numbers here. Let a computer do it for you. So this table that I'm going to pop up here shows the number of times that 80 seniors at Smithtown High School visited the Smithtown Pizza Place. So we've got number of visits in the month of August, and then how many times each student visited, or how many students visited that number of times would be the better way to say it. So like we had 12 students that went 5 times. We had 21 students that went 10 times, and so on and so on. If we wanted to do this set of data like we did a couple slides ago, we have to deal with 80 different numbers and finding the deviances of those 80 numbers, squaring those, make sure we're adding up the right numbers. That is a pain. So instead, we're going to let a spreadsheet do the work for us. Okay, so I've got the data here. You're going to have a copy of it. Actually, I'm going to make the copy right now so I don't forget, so that you can play along with this as I'm going if you'd like. All right, so we need to figure out the mean of this data. And to find the mean of this data, we need to know how many total times kids visited the pizza place. So we need to be multiplying the number of visits by the frequency, the number of students that visited that time. So I'm going to start with an equals, and then I'm going to multiply column A times column B. So like the students that went 5 times each went a total of 60 times. And I can drag this down, and that'll give me all of those, and then I want to sum that. So I want to know how many total visits we have. So our sum from C2 to C7 is 960. So if I want to find the mean, then I need to divide 960 by 80. All right, so the average number of times that each student went to the pizza place was 12. So that means that we can calculate the deviance here. Okay, so number of visits would be 5. So remember, for deviance, we're going number of visits are x minus the mean, which would be x bar, which is not there because it's hard to get that kind of symbol into Google Sheets. So we need to take equals our number of visits minus our mean. So we get a -7. And then we can use that same formula for all of these. Oh, I guess I don't need this last one. I don't need a total. Oh, and I have made a mistake. What mistake did I make? If I look right here, I am subtracting from a blank spot. So all my numbers are positive and they're all wrong except for the first one. So I need to go back to this top one and I need to put a cash symbol before the 9 there because that's going to tell my formula that I never want to get away from that 12. So now let's drag this down again. All right, and now we have the deviance. So because we are going to be looking for variance, we want the deviance squared. So I'm just going to hit equals, and then I'm going to click that box, and I'm going to hit Shift 6 to get the caret here, and then squared. So Shift 6 and then 2. So -7 times -7 is going to be 49. Okay, so we've got our deviance squared, and now we need to multiply that by the frequency of the number of kids who went at each deviance level, essentially. So that's going to be just multiplying column E times column B. So equals deviance squared times B. So we're going to get some large numbers here. And I'm going to want a total of these again so we can find the variance. So equals the sum of this whole stack of data, which looks like it's going to be 1,134. So our variance is going to be 1,134 divided by our 80 students. So equals 1134 divided by 80. So our variance is 14.175, and now we are almost there. We need the standard deviation, which is just the square root of the variance. So this is going to equal my variance, or actually there's probably a square root function. Square root, SQRT. So the square root of that cell right there, and we get a long number. So what I'm going to do with that long number is I'm going to round it off to the, let's say the hundredths place. So to do that, I'm going to go to Format, I'm going to go to Number, and I'm going to go to, how about this number right here? It looks like 2 decimal places. So our standard deviation of this data is 3.76. So our mean is 12, but our spread around that mean, and we'll talk about more what that means in 1.4 when we get into z-scores, but our spread around that mean is about 3.76. Okay, so that was a lot, I know. We are going to practice with this some more. I encourage you to practice with these spreadsheets instead of trying to do all of these calculations by hand, and I'll see you in class.